In this session, we're going to talk about quadratic equations and how to solve them. Quadratic equations are of this form: y equals a times x squared plus b times x plus c, where a, b and c are any constant numerical values. Here we're looking at y equals x squared, where a is 1 and b and c are 0. This time when we plot a quadratic curve, what we need to do is plot lots of different values, not just 3 values like we did for the linear graphs. So here I've plotted the curve from x equals minus 3 right through to x equals 3. Created a little table of all my results so that when x is minus 3 squared is 9, minus 2 squared is 4, minus 1 squared is 1, etc. right through to here. Then we can plot all these points on the curve. So the first one, minus 3, 9, then minus 2, 4, minus 1, 1, 0, 0, right through to 3, 3. As you can see, the general shape of this graph is a curve. For a general quadratic equation, it will be a curve like this, either curving up or curving down like this. As you can see, it does have a line of symmetry. That's always a good point to look out for when you're plotting quadratic curves. Make sure that the curve is a nice smooth curve, either going down and then back up again, or coming up and then back down again. If it starts to wiggle, then you've probably done something wrong when you're calculating your values. In general, if the value of the a, that is the number in front of the x squared, if a is greater than 0, then you will get this U-type shape here. Refer back to the x squared curve earlier on. When x was 1, which is greater than 0, then it will look like this. If a is less than 0, if a is negative, so if we had minus 2x squared here, then the curve would look like this. It would be a sort of N shape. As always, when x is 0, this term will be 0, and this term will be 0, and y will equal c. So again, the curve will cut the axis at 0, c. The general term for these types of curves is a parabola. When we talk about finding the solutions of a quadratic equation like this, there may be no solutions, like here, one solution or two solutions. When we talk about solutions, we're saying, where does this curve cross the x-axis? Here, this one doesn't cross the x-axis, so it has no solutions. We can either find these solutions graphically, drawing a graph and picking out the solutions, or algebraically, and we will talk about the algebraic ways in another screencast. When working out answers, you may need to find an approximate answer. We may need to use this curve and a straight line across from the y-axis and then down to the x-axis to get an approximate value. The next slide will show an example of this. Here we've got this curve here, 2x squared plus 3x plus 4, and it equals 16. This is our equation we need to solve. To solve it, we can plot the equation of the curve 2x squared plus 3x plus 4, and then we draw the line y equals 16. This is the line y equals 16, horizontal line here. And then where these two lines intersect, we can find out what the x values are here and here. Looks like approximately 2.5 and minus 6.5. And we can then put those answers back into the equation to give us our final solution. There are other ways of solving these, and I will do that in the next screencast.